I'm going to go through module 3.5 and 3.6. So we're almost at the end of 3. Um, Actually, I goofed here. Oh, no, well, if anyone did it, it's on them. But I moved. Originally, I was going to do 3.5 through 3.7 this week, but I wanted to slow down a little bit because we're a number of people that were, having some difficulties with, the ifs and the logical operators as well as the bitwise operators. So I made it through 3.5 through 3.6 this week and 3.7 next week. So that means I really need to move the quiz and the exam to next week. If you did it already, hopefully, it's still in the middle of the week. Not too many people get that much ahead. But if you did either of those already, then you're good. You won't have any quizzes or tests to do next week. But I meant to move that because I moved 3.7 down to next week instead of trying to cover it this week. Because understanding lists is pretty important in computing in general, and it's a big feature of Python because lists are used on a pretty regular basis in programming for all, basically they just hold lots of information in a convenient way without having to, create a variable for each piece of information. You just create a list and you can store a whole bunch of stuff in one place. So they're pretty important to understand, and both in Python and in any language that you might end up using. So I wanted to slow down and give you a chance to really work on the stuff that involves lists. So I'm going to go ahead and go through those, and then when we're done, because they are actually fairly small sections, when we're done, can go over anything from last week that anybody wants to, and or answer any questions about stuff that's coming up. So let's get through 3.5 and 3.6 first, and then we can do some review, or like I said, go over some assignments from last week, or even look at the ones from this week if anyone's. Well, I won't go over them like in a review sense, but I can, explain something that maybe isn't quite clear about the assignment. Okay, so this 3.5, like I said, a pretty short section. Pretty sure we got through 3.4, not entirely, but we got through the majority of what we needed to. So 3.5 is just a few slides, and it's talking about bubble sort. And sorting stuff in Python really isn't too frequently necessary, at least to do simple sorts, because as you'll see towards the end of this, there's a method for doing sorts, for sorting lists anyway. But there might be instances where you have to sort something that is not in a list, or if you're doing it in another language, another computing language, they may not have a sort method that you can just say, hey, sort, and boom, it's done. So understanding the algorithm will help you both in understanding logic and also understanding more about working with lists. So, in this first page, they just present the list that they're going to be working on, and they go through the process of what the algorithm is going to do, and basically what a bubble sort does. And there's other types of sort. This is one of usually the first one you learn as a programmer. It's not necessarily super efficient. It's efficient for a mostly sorted list. But for a bigger list that's really not even close to being sorted, there's other more efficient ones, but we're not really going to go into those. because this one's easy, reasonably easy to learn, and it uses, you know, some of the logic that you've learned. So it's a good exercise. All right, so here's your starting list. And so what we're going to do is we're going to, in order to do a bubble sort, we're basically going to look at each element of the list and compare it to the next element over. So we're going to look at 8 and 10. And since we want to go from the least number to the greatest number, you know, it's an ascending sort. If the element we're looking at is greater than the adjacent element, then we're going to swap those elements. If it's not greater, in other words, it's already in order from the perspective of just those two elements, then we're just going to leave it alone. Okay, so comparing 8 and 10, 8 is already less than 10. So from those two elements perspective, it's already in order. Those two are in correct order for each other. So we don't need to do anything. The next thing we do is look at the next two elements, 10 and 6. Now these are not in order because 10 is greater than 6. So we need to swap them. So we're basically going to put 6 where 10 is and 10 where 6 was. And that's what this next graphic shows the results of. Then we're going to go one more element over and compare 10 to 2. And again, 10 is greater than 2, so they're out of order. So we're going to swap them, and we end up with this as our new version of the list. And then we're going to do that one more time, and we're going to compare 10 to 4. And 10 is greater than 4, so we're going to swap those. So now we've gone through the list one full time, every element, comparing each element's adjacent element one time. And we see that we've got a little bit better order, but it's not completely in order. We still have, you know, these three to contend with. The only thing that's really in the right place is the 10. Okay, and the way that they describe it, why it's called a bubble sort, is because the 10 that used to be in the second element down here, it used, you know, in the second element here, has bubbled up to the top. So that's why they call it a bubble sort. So we basically just have to go through the list as many times as we need to until we no longer swap two elements. So we go through it again, and we're swapping the 6 and the 8, and then we're going to swap the 8 and the 2, and then we're going to swap the 4 and the 8. Okay, so we've gone through it twice, and we get a little bit better, 6, 2, 4, 8, 10, still not in order, and we go through it again and again, and eventually we're going to get it in order. Okay, so the trick is in writing the algorithm, there's two things that we're going to be introducing here. One is a variable that you use. It's generally called like a flag variable that tells you whether something happened or didn't happen. And what we want to find out if something happened or not is we want to find out so that we know that when we're done with the sort, we want to find out if we had to swap any elements. Okay, and if we had to swap elements in the list, then we know that we may have to go through it one more time, at least one more time. If we didn't swap any elements in our traversal of the list, then we know, oh, it's sorted, so we're done. Okay, so that's what this algorithm is going to introduce, is the idea of using a flag variable to just tell you, did something happen or not? Okay. Basically what I think I'm going to do now, because this is the full algorithm here, I'm going to bring in my version of it. It's pretty much, I think it's, maybe the variable names are changed, but it's the same thing as what the screen was showing, what the curriculum was showing you. So we start off with our list, and it's just a static list. And here's our flag variable. And what we're going to do is we basically want to go through the list until we no longer have swapped, made a swap between two adjacent elements. And we're going to do a while loop to say, we're going to keep going through the list as many times until swapped is false. So we have to set swap to true initially before we even start, so that we can enter the while loop. Okay, so we're making an assumption here that that there's going to be that a swap is going to occur, because otherwise we'd never get into the while loop to check to see and to change things. So that's what that is doing here. So while swapped, and then we immediately set swap to false, because now that we're in the loop, we're going to say, well, we haven't made any swaps yet, so we're going to set it to false. And then we start our for loop. And our for loop is going to go from the 0 element of the list to the one less than the last element, because we stop comparing, again, looking at this over here. When we get to the last element here, where was it? Here. When we get to this element in the list, we're comparing it to the last element. So we don't want to go all the way to the very last element and compare it to the adjacent element, because there is no adjacent element. That's why in our for loop, we use the range length of my list, the length of the list -1, because we don't want to go all the way to the end, because then we would be comparing the last element to some element that doesn't exist. Okay, that's why the -1 there. Otherwise, if we were going to inspect each element for some reason, then we would just say to range length of my list. But in this case, we're only going to the second to last, because as you see here, we reference the ith element, and I+1 gives us the next element, the one that's next to it. Okay, so we have our for loop. We're going to go from 0, because remember, range, unless you give it a different starting number, it always starts with 0 and goes to whatever the ending number is up to, but not including that ending number. Okay, so now we're going to compare. We're going to compare in the first case, the 0th element with the adjacent element. So the 1 element, my list sub 1. And if a swap needs to be made, then which means that the 0th element is greater than the one next to it, then it says swapped equals true. So that way we know that a swap occurred. That means we're going to have to go through the list at least one more time. And then we swap the 2 elements. And that's what this does. This says, give me the ith element and the one next to it, and swap it with the one next to it and the ith element. Okay, so that makes, in this case, well, 8, we wouldn't swap 8 and 10, but when we're comparing 10 and 6, we're saying my list sub 1, which is 10, and my list sub 2, which is 6, is going to now equal the opposite values. So 6 is going to be moved here, and 10 is going to be moved there. And that's how the for loop proceeds. Now, I just put this pass statement here. That's not necessary. The pass statement in Python does literally nothing. It basically says don't do anything, but there are instances, believe it or not, where you actually have to tell Python in a statement, don't do something. The reason I put it in this program was because these little red dots mean they're breakpoints. I'm going to show the debugging of this program, or let's say stepping through this program. And so when I tell Python to run it, it's going to stop here, and we're going to look at the variable values over here in this window, and then it's going to stop here after a swap has occurred. Okay, so let's do debug. And so whenever you have breakpoints set and you just hit the debugger icon, it goes through your program, and then it stops at the first breakpoint, which is line 8 in this case. So as we see, my list is 810.624. Nothing's happened yet. It's the same. And the swap variable is currently false. All right. I'm going to hit the resume button, and it's going to resume the execution of the program, and it'll stop at the pass statement if it gets into this if. Okay, so as you see, the first time that it hit the if statement where it was true, it stopped at my pass statement, and you can see the status of the list is now changed. The 6 and the 10 have been swapped. Nothing else has happened because it's only done one swap so far. I'm going to resume again. And when I resume again, now you see that the 2 and the 10 have been swapped. And do it again. And now the 10 is all the way at the top, or the end of the list. All right, so that tells me we're probably through to the end of the first pass. And so since we set swapped to be true within the loop, at least once we set it to be true, now the while loop is going to continue. We're done with this for loop, and the while condition is going to be checked. Swapped is true because we set it here when we did a swap. And so it's going to continue, and it's going to go to the next iteration of the for loop. We have to set swap to equal false, of course, because we need to know each time through whether we swapped an element or not. Okay, so it stops at that 862.410 is still the state of the list after the last pass. Now we get 682.410, so a swap has occurred. We get 628.410, so a swap has occurred. Chances are that 8 is going to bubble up to the top next to the 10. And it does. So now we have the 8 bubbling up to the top, and we are done going through the list that time. So it goes back up. Since we did at least one swap, it's going to do the while loop again. And then it hits the 4, the break point at the 4, and it's going to go through, and now we'll see that 6 start to bubble up. And now the 6 is bubbled up, and now we're in proper order. So at this point, it's actually going to go through one more time, because we did do a swap between the 6 and the 4. So swapped was set to true. It's going to hit the while loop, say, okay, swapped is true. It's going to do the loop one more time, but this time we're not going to do any swaps. You'll see that my second break point never gets arrived at this time, and we just end up printing the list. And it prints it there. Okay, so that's the idea of the bubble sort, and it's also showing you the use of a flag in programming. Flags are used very, very frequently in programming to let the program know if something has occurred. So in this case, whether a swap occurred in sorting that list. Okay. Any questions on that? And for your own, if you want to use breakpoints in Thonny, the way you do it is you have to have Thonny set to display line numbers. If you don't have it set to display line numbers, where do you go? You go to Options, Tools, Options, Editor, and Show Line Numbers. Okay, I think it's probably defaults to showing line numbers, but if it didn't, you got to check that box and it'll show you line numbers. And then once you have line numbers displayed, to set a breakpoint, you just double click at the line number, but it's got to be where there's an actual Python statement. You can't double click where there's no Python statement. So when I double click on 7, it doesn't do anything. That's why I had to put the pass here. I wanted to break after the swap had occurred, but so doing it at the next line made sense. So I just put a pass, which does nothing. It's just a don't do anything statement. And so once you set a breakpoint, then you don't hit run, you hit the debug, and it'll stop at that breakpoint, let you look at variables. To see the variables window, you just go to View and click on Variables. Otherwise, you won't see the variables by default. You got to turn it on. Okay. And then, of course, I showed you step by step. You can use the debugger. If you don't have any breakpoints set, you can use the debugger to go step by step through the program. Okay, step over, step into gives you, minute details of what's happening with each statement. Step over will just sort of do that statement, show any variable changes over here, and go on to the next statement. So, created the list, swapped equals true. That, there's nothing interesting to see by stepping into that statement. So I'm just going to step over it. And then once I get to the while loop, that's where I'm going to step into. Because if I just said step over, it would step over, the entire while loop. So I'm going to step into that. While swapped is true, swapped gets set to false. And then here's where you see the in range statement, and it evaluates the length of my list, which has a length of 5. And so it's going to give you that 5, and then the -1 is 4. So it's basically the range statement is then going to give you a value. It's going to show you here in a second, 0 to 4. All right, so that's what that evaluates to. So, and so now and see that little 0 there is telling you that's the first value of I. And I'm going to just step over that. Well, I'll step into that just to show it. So it's going to do that comparison. What's in my list sub I? I is 0, so my list sub 0 is 8, and it's going to compare that to the next element, which is I plus 1, which is the 1th element, which is going to be 10. So if 8 greater than 10, no. And so it just goes back to the beginning of the for loop, and now I is 1. And so forth and so on. I'm not going to step through the whole thing over and over, but that's how you can use the debugger. When you're done, you can either, and you don't need to see any more of the stepping through it, you can hit resume, or you can say step out, and it will go to the next major code block, which in this case was print. Okay. All right, so that's the use of the debugger and bubble sorts. Oh, and then here, you'll want to pay a little bit of attention to this one. This is doing a bubble sort, just like the other, The thing with this one is that it's getting the list, it's building the list from input from the user. The assignment that I have, one of the assignments I have you do this week is similar to this. It's not exactly the same, but it's similar to this in that you are going to build a list of, you know, basically names by continually asking the user to enter a name. You're not going to ask them how many elements. You're just going to do it by quitting when the person types exit. Okay, but you're going to build a list in a similar way as this, and then you're going to sort it. And then you're going to print it, and then you're going to reverse the sort and print that out. Okay, so you want to study this because this is close. It's not the exact, it won't be exactly what you do in your program, but it's pretty darn close. All right, and then see, like I said, pretty short section. If you'll, like I always say, do these exercises, because if you're not getting these right, then you don't understand the material, and you need to go back through it, or drop in an office hours, or send me an email for an appointment or whatever. You should be able to do all these exercises just by taking a little bit of time and looking at them. I'll warn you now, there probably wasn't too much difficult stuff in the Module 2 exam, where you had to like look at a program and figure out what the output was. But in the Module 3 exam, you're going to have to look at a program with 4 lists and, sorry to say it, bitwise operators and things like that. And you're going to have to figure out what the results of the program are, and choose the correct result. So being able to look at a program and figure out what it's doing and what its results are is extremely important, not only for just general programming purposes, but for real life, to be able to figure out a program and see what it's doing. Debugging your own programs is one. Okay, so we taught you about the bubble sort, but there's also the sort method, which of course is cheating. Not really, it's not cheating, because I actually did a little thing today to see if the difference between in the performance of Python with the bubble sort, a written bubble sort versus Python sort. Let me see if I can find it. Okay. So there's a timing function called time.perf counter, and basically this gives you a value. I think it's down to milliseconds. But in any case, I'm going to set a variable to the counter before I start the major part of the algorithm, and then I'm going to set a variable once we're done with the while loop, which means it's sorted, and then I'm going to print end time minus start time, which will tell me the time it took to do that sort. And then I'm going to recreate the list because it's already sorted. So I recreate the list. And then I do the same thing. I set a start timer. I use the sort method and do an end timer, and then print out the difference between the two. And then we'll see which one goes faster. So the bubble sort took 1.069 times negative 10 to the 5th power seconds to complete. So 0.00016 or something like that. A pretty small number. It did it pretty quick. But the sort did 8.99 times 10 to the negative 7th. So Basically, they're just about, it's just about 10 times faster, the sort algorithm that's used in the sort method, just about 10 times faster. So that gives you an idea that bubble sort, not terribly efficient, and clearly the sort method within Python, at least for this kind of list, is more efficient. Yeah, here's a better look where you've got 1.06 times 10 to the negative fifth, 1.0 something times 10 to the negative six. So about 10 times faster was the sort method. And you can use this. All you have to do is import time into your program to be able to use this. And so if you're ever curious, you know, if I do my for loop this way, or if I do it this other way, which is faster? Sometimes it might be negligible, the difference. Other times it might be fairly significant. All right. So now we're going to look at different list operations. So I'm going to, instead of using their example, I'm going to basically just put copy and paste my code up there. Actually, no, let's do it this way. Let's bring in the Thorny, do it through the Thorny console. All right. Okay, so I'm going to create a list. This is just giving you an idea a little bit about how some of the inner workings and the way that Python handles lists, which might be important depending on what you're doing with your program. So I created a list, and then I say, I'm going to basically say, create a new list called L2 and assign it to L1. The question is really, is that a new list or not? Okay, so, or is it just, you know, is it a copy of L1, or is it just a variable that points to the same place as L1? So that's really the question that we're trying to answer here. And I'll answer it right now by saying it's not a copy of the list. L2 and L1 just point to a place in memory where that list exists. So they both point to the exact same thing. And to prove it, I will delete an element of L2. I'm going to delete the two, basically, the index one element. And then when I do that, let's take a look at L1. Well, first let's see the results. L2 looks like 1 and 3 now, as we would expect. L1, also 1 and 3. So what I do to L2 happens to L1 and vice versa. If I do something to L1, add a number to it, for example. So now I've got 3 numbers again, 1, 3, and 5 now. L2 is exactly the same. So when you use the assignment operator and you would take a variable and assign that variable to an existing list, you're not making a copy of that list. You're basically pointing both variables to the same list. Okay. Now there's, I'm going to use the delete command again. This time I'm not going to delete an element of the list. I'm going to delete L1. Okay, so I deleted L1. What do you think about L2?
It's gone.
You would think that would be gone. Okay, and that's the kind of strangeness until you understand. If you worked with C, then you were probably introduced to pointers and stuff. And variables in Python that that essentially hold lists are really pointers to a place in memory where that list is. Okay, so that's why L1 and L2, they just point to the same place. Well, when I delete L1, I'm actually not deleting the data, at least not yet. And that's because what I'm doing is deleting the variable L1, but the L2 variable still lives. And it's still pointing to that place in memory where that list lives. And so L2 is fine and dandy. It's still there. So in this case, where I deleted L2 and an element of L2, I actually went and changed the list. So they're both pointing to the same place, and what they're pointing to changed. In this case, all I did was delete the variable. It didn't change the contents of the list. Now, once I delete L2,
is there a command that you can look to see what variables point to? If there's other variables, without knowing.
right? Yeah. Can you tell if there's a reference to let's say a
Multiple variables
that's still alive? Yeah, I believe there is, and at the top of my head, I can't remember what it is, but well, once you delete, let me see if there's a method for list that will tell you the references to it.
The index or something.
I can't remember what index does. I don't know if it requires an argument. So
Yeah.
no, so that just oh, okay. I know what index does. I forgot. I actually used to know, and it's one of those that I don't use much, so I forgot. That tells you the index into the list where a particular value can be found. And so it returned 0 because the value 1 is in the 0th element of my list. And if I put 5, it will return what do you think?
False.
Well, here's my list: 1, 3, and 5.
Oh, okay.
So
no, there's no 5th position, right?
No, but that's not what it's asking. It's saying where can the in what part of the list?
Oh, okay.
Which element of the list can I find the number 5?
Okay.
So it should return a 2, right?
Right.
Right. Now, if I say 6, there is no 6 in my list, so it says it's not in the list.
Okay.
All right. So, but it gave you an error, so there'd be, you'd want to, if you actually had to do this for some reason in a program, you'd want to verify that you're not going to throw an error on your users. Let me see if there's. I don't see. Not seeing a something that'll tell me the reference. There might be a function or something that can tell me how many references to a particular variable there is, but I don't know it off the top of my head. So now there is a where is it? Let me do a quick search here. Okay. All right. So let me do that. So did I get rid of L2? No, I still have it, right? So this will prove that. So ID of L1 is that number right there. That basically is something just used internally by Python to say kind of where does a particular variable point to in, might even say in memory. So if you notice, ID of L1 and ID of L2 return exactly the same thing. Okay, that's because they are pointing to the same place. So whereas if I do this, I'm going to change.
Same thing in Linux, kind of.
Now, L1 and L2 are still the same, but if I ID L1, it's still that 736. If I ID L2, it's now a different value. That's because this statement up here, this is basically making a copy of the list. Okay, so if you want the two variables to point to the exact same list, you just say list name equal list name. If you want to make a copy, you say variable name equals existing list and then brackets with the 2 colons. The 2 colons, I actually don't, you don't need 2. Yeah, just 1 colon in. That basically says, give me the whole list, make a copy of the entire list. Just to show it to you, if I say L1 colon, it shows me the entire list. Okay, that's list slicing. That's a slice of the list. But when you don't put any values on either side of the colon, you're saying, give me the whole list. Okay, starting from the beginning, ending at the end. Okay, so now we're on to list slices. So that's a good segue into list slices. We talked briefly about slices last week as they pertain to strings, but it's pretty much, they work the same way with lists. Very few differences. So let me make a list here, a new list. And I already showed you this, where you use just a colon inside the brackets to say I want the entire list. Okay, so that essentially makes a copy, and that way you can assign that copy to another variable to make a true copy of the list, as opposed to just a one list with 2 variables pointing in the same place. And then you can, give it a start and end index. Remember that with the start and end, the start is the the first element that you want to look at. The end is up to but not including the number 2 index value. So this is just going to give me 0, which is 5, and 1, which is 8. It won't give me 2. So the second part, the second number in the slice says up to but not including that element of the list. So it gave me the 0th and the 1 and the 1. All right. And then if you want to start from 0, you don't have to put 0. If you just omit the 0 and put the ending number, it's as if you put 0. So these 2 statements are identical. They do the exact same thing. Which one you use makes no difference in terms of function. And then if you want to start at a particular place and go to the end, you just do the starting point and a colon. You don't need to specify the end value or the end index. And then if you want to go from a particular place in the list to the second to last, because remember, -1 when it's, let me just show this again, because this is a little weird. I remember when I was working with lists for the first time in Python, I had a bit of a hard time grasping this. When I use -1 as an index, okay, this is not a slice. It's only a slice if you've got that colon as part of the syntax. When it's just a number, then it's an index. When you use -1 as an index, that says, give me the last element, okay? When you use it as part of a slice, that says, give me the last element up to but not including the last element. Because remember, the ending value in a list, the second value after the colon, is up to but not including. And so -1 says last element, but when used with a slice, it means up to but not including the last element. So you get just the 2 and the 3. The second element, the number 2 index element and the number 3 index element. You don't get the 9 because that says up to but not including the last. Now this one's a little bit different. What this says, I've got 2 colons in there and a number after that. And that number after that says how many the number of elements I want to skip or skip by. So this is saying, give me every second element of the list, starting with 0. So it'll do 0, the 0th element, and then the number 2 element, and then the number 4 element, right? 5, 2, and 9. 0 element, the number 2 element, and the 4 element. So that way, so it's skipping through by 2s. And then somebody's already discovered this one because they did it in one of their assignments, which was nice to see. And what does that do? Because I think it's somebody here.
Does it reverse it?
It's going to give me the reverse of the list. So it's basically saying, I want all the elements in the list stepped by -1. So it's going to start at the last element and go to the first element, or 0th index element. Okay, so that's kind of cool. Now you're going to be asked to in one of your assignments to modify one of the labs, and instead of creating the new list in order, you're going to be asked to create it in reverse order. I'm telling you right now, you're not to use that to just, because that's not really any work. The actual assignment is only really changing one statement to get it to go in reverse order, but I'm going to leave that up to you to know what that statement is. So that's a nice little statement. That actually returns a new list, okay, in reverse order. So if I do L1 equal, say, L4 equal list ::1, this is assigning a new list in reverse order, L4. So we look at list. List is still in its original order. L4 contains the reverse of it. Okay, so that's a difference between the reverse method. Okay, I think we haven't gotten there yet in the curriculum, but it's coming up pretty quick. There's a method that reverses a list, but it doesn't return a reverse list. It just reverses the list in order, in place. So I just reversed L4. Okay, but I can't do this. I can't assign a new list L4.reverse. Okay, L5 is nothing because L4.reverse doesn't return anything that you can assign to a variable. It just reverses the list in place. It doesn't create a new list that you can assign to another variable. So if you need to reverse a list and assign it to a new variable, you would use that method. If you just need to reverse a list in place, you would use that. But for our upcoming assignment, you can't use either. Okay, I want you to think about how you can get the list reversed without having to do much work, including using those methods. Okay, so let's go on now. I think we are to we actually covered most of this. Let me see if there's anything that I didn't cover. We covered negative indices in slices, start and end. Yeah, so we really, I think I covered everything up until this point. So the in operator is a nice operator. I think I showed it to you with respect to maybe with strings, or I might have used it with lists the other day. But it's basically a quick and easy way to find out if an element is contained in a list. So it returns the in operator, the way it's being used here, is going to return a Boolean, true or false. So let's get back to what does my list look like? 58239. So I can say 5 in list, and that will return true. I can say 6 in list, and it will return false. Okay, so that's pretty basic. It just is the in operator is used, unfortunately, in a couple of different contexts, like in the for loop for I in range kind of thing. But in this particular instance, it's used to return a true or false, if something is inside of it. I think you might, honestly can't remember if you can use it with a string. Yeah, okay, so you can use the in, I kind of figured you could. You can use the in operator to look for a string within another string. So I could even do it like this, not just a single character. I could do, you know, GA in S1. Okay, and GA is in S1 right there. Okay, so that's a nice feature. Most other language have something similar, but they're a little bit more complicated to use. The in operator is really straightforward and easy to use. So you can use it to find out if an element is in a list, or if it's if an element or a string is contained within another string. Let me see what else you can do. Let's see. Oh, not in, of course. So you can, and let me use variables with this. So I'm going to say x equal 9. And so I can say, and obviously you would use this in an if statement or a while loop, you know, as a condition. X not in list. Okay, so is X in the list? No, is 9, you know, because I assigned 9 to X. X not in list is false because it is in the list, right? Negative logic sometimes, you know, gets past you the first time. So X not in list returns false because X is in list, because 9 is part of that list. Now, if I say 12 not in list, then that'll return true because 12 is not in that list. Okay, so that, you know, I think there's one slide on that in the curriculum because it's pretty straightforward. Okay, in this particular example, they are basically using, well, first they're using the way that you would probably normally if it wasn't Python, that you would go through all the elements in a list. So they're basically saying for I in range, they're starting with 1 here because they set the largest variable to the 0th element, right? And then we want to go through to the end of the list, essentially. And then they're saying, okay, if the element that we're looking at is greater than the largest variable, then swap, change the largest variable to be the new element. And so this is, basically doing a max function. It's finding the maximum value inside a list. Okay, so that's using the for I in range, and then over here is the same thing using the just for I in list. But it does the exact same thing. It produces 17. And I'll change this because 17 is the first number. It's also the biggest, so it not really doesn't seem to be doing anything, but I'll put it there in the middle just to show that it is indeed checking all of them and making 17 the largest number. Okay, so the shortcut way to do that, I would hate for you to actually write a little algorithm to find the largest value in a list. Instead, I would want you to use the max function. Oh, it's hard to see. I'll get rid of that print and just use that. Okay, so get the same thing. I could actually get rid of this entire algorithm, right? There's my list and there's my algorithm, boom. So for something like this, the curriculum has you do these exercises because you don't always have a function to replace an entire algorithm, like sorting or reversing a sort or max, or there's a corresponding min function that does exactly what you would think it does. It finds the minimum value, which in this case is 1. You sort of just need to go through, the curriculum will tell you what some of these functions are that are available, but in order to learn it fully as you're trying to write a program, you either have to study the documentation or you just go to, the python.org website where the official documentation is, or your favorite place that really covers the language really well, and do a search for what you want. So if you went and said, find largest element in a list, or find largest, it'll probably come up with, the max function. Sometimes you have to know how to construct your search to find the appropriate, and in some cases you won't find a function, but there's a lot of basic stuff that we used to have to write all the algorithms for. In the first development system I used, writing C code, almost none of this was available. There was just the basic C language, and it didn't have a max function and a min function. If I wanted to find out the max of value in an array, I had to write that algorithm just that we saw. And then I would turn it into a function that I could call myself. But nowadays, the programming libraries are chock full of really useful functions that do stuff like this for you. Doesn't mean you don't have to write code, you still have to write it, but there's a lot of grunt work code that you don't have to write anymore. But you do when you're learning the language, because if you don't write this kind of basic stuff, you won't learn, logic. And that's the biggest hurdle, is learning logic. The language is almost secondary. Okay, so this next one is a little different. It's basically checking to see if a element is in a list, but it's not just seeing if it's in the list. It's finding out what its index value is. Now, we just saw that there was a method for that. The only problem with that method is that it will throw an error if you say list.index and you give it a number that doesn't exist in the list. Okay, so so this is sort of the brute force algorithm to look to see if an item is in a list. And then since it uses a counting for loop, it also saves the index number. Okay, so that's well and good. What I would do, knowing that there is a index function, I would say, let me put the original stuff up here. Okay, all my syntax correct. Okay. All right, so I basically, reduced this program to something much smaller using the fact that there's an index method that's part of lists. And the only thing I had to do is I had to make sure that it was first in the list before I tried to use the index method. Because if I didn't and it wasn't in the list, my program would throw an error, and you don't want that. So I had to first find out, is it in the list? And if so, then I can print out where it was found. Found at element 4, 0, 1, 2, 3, 4. Okay, so do you see how this here, we'll change it to make sure that it works for not found. Okay, so do you see how this code here essentially replaces all that code? Now, again, this, as for an exercise, you should definitely be writing code like this. But once you feel real comfortable with all the logic of programming, that's when you start to look for these nice little shortcuts where you don't have to write the brute force algorithm to find the index value of an element. Okay. And again, if you're like, well, how do I know if, a method exists for what I'm trying to do? That's where you just use the dir command in the console. And Python knows that if I put empty brackets in there, that means I want to find out all the methods available for lists in general. Okay. So like I said, most methods don't have the double underscore in front of them. So most methods are just these. Okay. So find out, play around either, or just go to the documentation and say, what does append do? What does clear do? What does copy do? Some of them are self-explanatory. Count counts the number of occurrences of a particular element in a list. Okay, and we saw what index does. Come on, what's the deal here? Why can't I grab that? Huh. It's not letting me grab the. It's not letting me grab Thawny to move it out of the way here. So I will just move it out. See if I can. That is the weirdest thing. Huh. Stupid Windows. I thought it would let me minimize it. Okay, let's go back to the curriculum and see if there's anything else that we haven't covered. Okay, so what does this one do? Yeah, is this the one I have you do the exercise for? 3619, yeah. So let me show you to make sure everyone's clear here. Well, let's look at the lab first. So you're starting off with an initial list. And what you're supposed to do is you're supposed to write the code that will go through this list and create a new list of only the unique elements. In other words, an element like 4 is repeated 3 times. So you only want it in your new list once. So when you're done, you should end up with 1, 2, 4, 6, 9. Okay, so you're not going to repeat any element. So that's what the program that you're supposed to write is supposed to do. My twist on it is that you should create the list in reverse order to begin with. Okay, that doesn't mean you create the list and then use either the reversing. You shouldn't use reverse or the double colon -1 operation. You should create the list in reverse from the get-go, and you shouldn't change the original list. Okay, so any ideas on how you might do that? Just anybody? Let's look at what the solution here is. That's part of the solution.
The range function.
Okay, so this is their suggested solution, and I think probably by now everybody knows about the little light bulb that will show you the lab solution if you click on it twice. At least I think it does it for most of them, if not all of them. So hopefully I'm not giving anything away here. So this is their solution. They have my list equal, that's the original, create a new empty list, and then they say for number in my list. And then they're basically saying, if the number in the original list is not in the new list, then add it to the new list using append. Okay, and what does append do? It adds it to the end of the list, right? So you're basically going to get these numbers in order, in the same order that they're presented in this list: 1, and then 2, and then 4, and then 6, and then 9. Okay, so any idea, and then you make a copy of it. You don't really, I don't care if you do that or not, but so that's one way to add numbers to a list, by doing append. What's the other way?
Range.
Hmm?
Do a range, right?
No. There's a method to add values to a list, just like append.
Oh,
It's different than append.
add values.
Yeah. Look at these. Okay, we know what append does. And we don't none of these sound like it.
Insert.
There you go. That sounds like it's adding something to something.
Yeah.
Okay, so those of you that attended tonight pretty much have the solution. Those that didn't, don't. So, but we did show the difference between append and insert in a previous Zoom. So let's see. So I was wondering what that means, generator. What?
I sent a ping of snip of my thing. It was an if, not the is numeric for I in range 4. And it comes back with that when I'm doing the debug. I just wondered what that meant.
What is this? Does this have your code in it and everything?
It's just a snip of a Thani screen.
Okay, we can take a look at that at the end here,
Okay.
which we're almost at there. So actually, I think we might be there. Yeah. So the next thing is a section summary. So make sure, if you're not understanding this, going through these exercises will tell you how well you understand it. The other thing is you're going to have, like I said, once we're done with section 3, you're going to have to, in the exam, you're going to have to trace a lot of little programs that have loops and stuff, and you're going to have to figure out the output. So you got to, doing these exercises will help you get good at that if you're not already. Let's see if there's anything else here. Okay, so I think this was, let's see, what was the other assignment here? Sorting a list. All right, so let's look at that one. So you're going to you're going to ask the user for a name. You're going to put the name in a list. By the way, this assignment has nothing to do with the threaded assignments you've been doing, although it uses some of the same code, obviously. But you ask the user for a name. You're going to put each name as they enter it into a list. Well, after they enter it, you're going to put it into a list. And then if the name is exit, you're not going to put it into the list. Instead, you're going to print the list. Then you're going to sort it using bubble sort, print it again, and then reverse it using a single statement. Here's where I let you use either method for reversing a list that I showed you before. So you don't have to do this in any manually in any way. And then you print the list. Okay. So that's what that assignment's all about. And that's it for this week. Just those 2 assignments. I wanted to lighten things up this week and next week, even though you do have the quiz and the module test next week. But in terms of adding to the threaded assignment, I wanted to give a week off because some people are still having trouble finishing up number 4. And there isn't a number 5. I don't know why I skipped number 5, but I did. I think what I did was I made, instead of 5, 6, 7, 8, I just did 6A, 6B, 6C. For some reason, I skipped 5. So if you're wondering what happened to assignment 5, it doesn't exist. So that'll be next week. We're only covering 3.7, and 3.7 is reasonably short. It talks mostly about 2-dimensional lists or even 3-dimensional. And it also talks about another subject called list comprehensions, which is a fast way to make a list. So this is our list comprehension. It's basically creating a list with one line, one statement line. Okay, so that's next week, though. So the amount of material to cover this week and next week is pretty small, so you'll have more time to work on assignments and studying for those that test. Okay, any questions before on what we just talked about before I go and ask if you have any questions about last week's assignments? No questions on what we just covered? Okay, So that means everyone's got it and won't have any problem doing the sorting and the other, the two sorts. Okay, good. All right, so looking back at last week, there was a good number of assignments, 5 different assignments. So which one would you like to go over? Anybody?
Bitwise operators.
Bitwise operators.
Okay, I got 2 for bitwise. And
Going once, going twice, sold.
all right. Okay. So Stephen, is your let me see if I can look at your thing real quick. Did you want to stick around, Stephen, for going over bitwise operators, or do you have it down? You're muted.
Okay, I'm talking to nobody. That was what I wrote there is the actual statement I put in there. And when I do a bug through it, it comes back with, it says,
so what you're doing in this, you're in proper use of the not statement. Not is to be used when you're saying like not in, like we just saw, in or not in.
Okay.
And when you are basically, oh, wait a second. Oh, I'm sorry, I read this wrong. Maybe you don't. Maybe you aren't using it incorrectly.
Well, if you look at it's covering up the actual statement.
Okay, so
and I wrote it in the message there.
If not generator octet, not octet in list I. Octet in list I dot is numeric for I in range.
What I was trying to do there.
Trying to do there, yeah.
It is you take each individual octet, position, because I changed it to an integer list.
Yeah, I see what you're trying to do. Yeah, you can't do it. You can't do it like that. The for loop. There's 2 places where you're going to see a for loop, or the for whatever statement. One will be it starts. It is the beginning of the command. So for I in range, blah blah blah. The other will be in what we just saw. That's what you're trying to do, a list generator. I mean a list comprehension.
Yeah.
Octet in list equal int. Okay, so
Which assignment is this one?
so is it the if statement that it's got a problem with, or is it the not generator object general expression?
It's covering up the statement. If you look at the chat message, that's the actual statement it's covering, and that's where it was erroring.
No, because what you put in the chat message is your if statement up here. If not len octet list.
Nope, it's below it.
I didn't go down far enough.
Yeah, well, yeah, you can see it there. It's if not octet int list I is numeric.
Oh, I see. Okay. All right. If not octet in list I dot is numeric. Okay, so what you need to do there in that if statement is you're really going to have to
True or false, right?
Instead of trying to do that all in one statement, you're really going to have to
trying to validate that is actually a numeric number, right?
Yeah. So you need to create the list first, and then check.
And I did in the statement above it. It is an integer list for. I did. In the one that's not covered up there, you can read half of it there.
Right.
I made it into an integer list.
So this is checking the number of octets. That's good. Then you're trying to create a new list.
With the as an integer.
So and that statement looks like is working. Okay. So now you need to, the statement that you're looking for is just, you're going to have to do a regular for loop and say, for I, for X in octet in list, and then say if not dot is numeric. Okay. Or the other way is you just say, you just do one big long if statement. You just say if,
I was trying to get away from it. That's why I try to throw a range in there.
Now that won't work, unfortunately. Yeah. Octet in list 0 dot is numeric. Okay. And, or is it or? Yeah.
Let me ask you this though. Wouldn't it already point an arrow if I tried to make it an integer list and there wasn't integers in there?
You made an integer list, right?
Right. So I mean, I'm saying is,
so you're basically gonna have to have a long if statement, just like this,
right,
and check all 4 octets. Or you could do it in a loop, but you can't do it. You've got your loop on the same statement as your if statement, and that's not allowed.
I do that all the time. Right? It says whatever that error is, it throws back to me. You can't.
Yeah, talking about a generator, there is something called a generator in Python that basically generates a iterable object. So it basically, you confuse the hell out of
it. I think I did too, out of myself too.
So what you need to do is just be more direct and look at all 4 octets to see if they're numeric.
Right. But now, like I said, though, where I make an integer list, if there's an element that I'm trying to put in there that's not an integer, it's going to throw an error already, wouldn't it? It's not going to put, if somebody put, some 198.abc, it wouldn't be able to make an integer list out of it, right?
Right.
Take the string ABC and.
But right. So you don't want to make that list. You don't want to try to convert to integer until you've already checked that they're all numeric. Yeah.
Right.
So you want to check for numeric that they're all numeric before you actually create the integer list. Okay. So you just have things, you're the cart before the horse there.
Yeah. Okay. I was just curious what that, because I went through and tried to debug this, and I was just like, "What the heck's going on with that? That doesn't make any sense to me."
Yeah, it doesn't like that syntax. Okay, there, finally got the funny where I need it. Okay, so let's look at Bitwise. All right, so here is your assignment. So the purpose of the assignment was to, obviously to learn how to use bitwise operators. The other part of that is letting you know the kind of the use of bitwise operators. In this case, what we're doing is we're storing the answer to 4 questions in a single, really in 4 bits of storage. Whereas if we didn't use bitwise, we would have to basically say, have 4 variables that contained, Y or N or yes or no. What was it? Income. So we'd have to have 4 separate variables. And while that might be okay in certain applications. When you can store data in a much smaller space, because a string, let me see if I can remember the function. Dang it. I know that there's a function. It just what the name of it is escapes me. To say how much memory a variable is taking up, and a string takes up a lot of bytes, probably 10, 12 bytes for even a very small string of one character, just because there's a lot of overhead to go with every string. Even a simple integer variable takes up more than just 8 bits or so. So in some cases, you do need to conserve storage. And if you are storing just binary data, yes or no, on or off, that type of information, then storing it as a binary bit, makes a lot of sense. Sometimes you don't need to do it if you've got all the storage and memory in the world, like most PCs have. But if you're writing code for a microcontroller or a database, or writing code that of the data that will be sent over a network packet, where you don't want to make those packets too big because it slows things down, then storing it as efficiently as possible is a good thing. So that's what we're doing here. We're storing the answer to 4 questions, or in this case, 3 questions, in just 3 bits. And in a single byte of data, we would have room for 5 more questions. In a word of data or an integer of data, we would have room for 32 if it was a 32-bit word, yes or no questions. So you can store a boatload of information if that information is binary, yes or no, on or off type stuff. So first thing that we do here is we have to create a mask for each question. The mask is simply, we're setting a bit, a single bit, in the variable so that it can be used to turn on the bit in the binary data that we're collecting. So in this first one, and I used powers of 2 to assign the values. You could have just used what the result of 2 raised to the 0 is, which is 1. So you could have just as well just said 1 and 2 without these powers of 2, right? So you could have just made it that. That would work perfectly fine. The only reason I did it this way is to demonstrate that we're storing a single bit of that is being turned on in each of these masks. In this case, the 0-bit, the 1-bit, and the 2-bit. Okay, but if you use just 1, 2, and 4, or 8, or 16, that would be fine. What you can't do is use a value that where more than 1 bit is turned on. So you can't say married equals 3 for your mask, because if I look at the binary of M now, there's 2 bits that are turned on. And so that's not yes or no, that's 2 yes or no's, right? And that's no good for when you're asking a single yes or no question. So it's got to be a value that a single bit is turned on in the integer. And that's why I used powers of 2, because that's guaranteed to be a single bit is turned on. 2 to the 12th even. 1 bit is turned, that's a big number, but only 1 bit is turned on. 4096. And the way I know that, well, I know my powers of 2, but besides that, I know that if I look at the binary of 4096, again, 1 bit is turned on. Okay, so That would be a perfectly valid mask to use in a problem like this if you needed as many as 12 bits. All right, so we only need 3, so I only used, 2 to the 0, 2 to the 1, 2 to the 2, 1, 2, and 4. And then we assign, that is what is going to collect our data. Okay, so we assign it, we initialize it to 0. So we don't know anything about the person we're asking these questions of. So we're going to basically say all the answers are no, because that's what a 0-bit tells me, because that's the way we're using the bits. 1 means yes, 0 means no. So we made all the answers no to begin with. And then we asked the question. All right, is your income greater than 50,000? Yes or no? Now what I did, and you didn't have to do this, but it's good practice when you're getting input from a user that's only used internally by the program and isn't going to be printed out, later on. It's a good idea to force the input to either uppercase or lowercase, so that when you compare the input to the answer, you can just compare it to, in this case, uppercase. Because otherwise, if the person entered lowercase yes, and I compared it to uppercase yes, it's going to say no. So it would be as if they entered no instead of yes. Same thing, why yes. They don't equal each other. They have to be of the same case. So you can't count on your users to always enter lower or always upper. You just can't count on them putting it in the right case. So you force it by using the upper method. And just to show you what that does. It forces it to uppercase, okay? It returns an uppercase. So if the answer is yes, then we take our binary data and we are going to assign it to our existing binary data, which in this case happens to be 0. And we're going to use the OR operator. And remember, OR is the truth table for OR is always going to be 1 if either one of these two values if either one of these two values in the corresponding bit places is binary 1, then the result will be 1. It'll only be 0 if they're both 0. Okay, well, income mask has the rightmost bit set. So income mask again looks like this. Oops. Oh, I can't look at it until I've run the program once. So let me just assign it. Okay, so income mask looks like that. And then the other mask is married to 1, and the other mask is so we look at what those are in bin. Okay, married
So
looks like that in binary, and yeah, age looks.
You're calling it a mask. Is there like
Why do I call it a
for
mask?
that, or
Yeah.
it just seems like you're assigning a variable, but I don't understand if the mask.
Why am I calling it a mask? It's called a mask because I'm going to use it a mask is generally used to either set a bit in another variable or clear a bit or to test the value of a bit. Okay, so the example that I usually use is an IP address. So when we have an IP address, and this won't work because Python doesn't know about IP addresses, but I wrote a program that'll do it. But so when you learned about IP addresses and subnet masks, it's called a subnet mask because the bits that are turned on represent the network portion of the address. So the bits that are on, the first 3 octets are the only thing that we're concerned about. And so you turn on bits when you are interested in those bits later on in your program. You turn the bits on in your mask if you're interested in them, and you leave them off when you don't care about them. All right, so a mask can do really 3 things. It can set a bit using an OR operator. It can clear a bit using the AND operator and the inverse of the mask. And it can be used to check the value of a bit. Okay, and always just a single bit. And that's just the typical term mask that has evolved out of programming, because but the zeros in the zero bits in the value mask off all the other bits in the variable you're testing against, meaning that you don't care about those bits. You're masking them off with the 0. Okay, so in this case, we start off, bin data is 0, and we're going to OR it with our income mask. And OR always will turn on the bits that are 1 in both variables. And so bin data has no bits that are turned on, but income mask has the 1 bit. So when you OR those 2 together, you're going to get the 1 bit being turned on, and that will be assigned to bin data. So bin data equal itself or income mask. What did I not have? Oh,
Probably because you haven't run it yet.
well, I didn't assign bin data to a value, and I need to capitalize in both places. What? Ah, I misspelled it. Okay, so now bin data is 1, and if we look again at, it holds the binary of the result of the OR operation between itself and income mask, which was basically ORing 0 and the value 1. So again, looking at the binary, okay, so it equals the binary 1. Now, this is not something you had to do in your program, because since we're starting off with the binary data being 0, which means all the answers are no, then you really don't have to do anything if the answer is no. But in real life, you almost certainly would, because in real life, you're probably pulling this binary data from a database, and this could be the 2nd, 3rd, 10th time that this user, it could be like census data or something. Last time their income was greater than 50,000. Now it's not. So the answer would be no. And you would have to clear the greater than $50,000 answer and make it no. And that's what this does. When you AND the inverse, and that's what the tilde operator is the inverse of the mask. In other words, all the bits the inverse means all the bits that were 1 are 0, all the bits that are 0 are 1. So just to show income mask, inverse. Unfortunately, -2, that's what I talked about in my in that announcement. that's the invert. That's when the leftmost bit of a integer is set, it becomes a negative number, and it uses something called 2's complement. We don't really care about all that. If anyone did what I did here and did the inverse of a mask, and it'd be, why is it -2? You know, that doesn't make sense. For now, just ignore that or read the article I pointed you to in the announcement. But if we look at the binary, oh shoot, it's not doing it. That isn't what I was hoping for either. Yeah, when you use the inverse function, it really only does what we expect it to do when it's coupled with the AND operator. I'll just leave it at that. Because once you have negative numbers, when you try to print them out in Python, it gets confusing as to where that negative number is coming from. So we're going to stick at the binary level here, and just know that if you need to set a bit, you use the OR operator. If you need to clear a bit, in other words, make it 0, you use AND with the inverse of the mask. All right.
And
so,
quick question.
Yeah.
The AND operator and the OR operator there, these only apply to bit operators, right? In Python programming. So we'll never see those anywhere else.
No, you will see the AND and the OR operator in bit operations in the C language. You'll see it in a lot of languages, as a matter of fact.
Okay, but yeah, in Python, it's only for these things.
C language uses AND and OR like this for bit operations, and then they use, instead of the word and OR for logical, they use double ampersand. So in C, double ampersand means what to Python is the word and, the AND. And so anyway, you probably don't need to know that, but for those that, you know, have done some C, which I think at least somebody here has, you know, they know that Python uses the word AND for logical operations and ampersand for bit. C uses ampersand for bit and double ampersand for logical. Okay, so this sets it, that clears it. So if it's yes, you set the bit. If it's no, you clear it. And then you ask the next question. Are you married? Yes or no? Answer is yes, you set the bit. No, you clear it. Okay, so if I were to say that I answered yes to I'm married, then that's going to set the bit in bin data, and now it equals 3 because both the 1-bit and the 2-bit are set. And again, to show it in binary, both bits are set. So that's what that OR operation did. It didn't actually do an addition operation of adding 1 and 2 together. It just simply set that bit there. The 1 bit was already set in bin data from the previous question, and now that bit is set. And then, are you older than 30? Do the same thing. If I answer yes, it's going to do this operation. And again, we'll see that now that bit is set. Okay. And then if I had another question that used a different mask, let's say it used a mask of that had value 64. Okay, that's going to end up setting the 64-bit. Okay, that right there is the 64-bit. All right, so it simply sets the bit that is turned on in the mask. In this case, the 1-bit, the 0th bit, the 1-bit, or the 2-bit. All right, so once you've set your bits as necessary, depending on the answer to the question, then the assignment just says print it out in decimal, which is what that'll do, and print out the binary version, which is what that'll do. So that's what that print statement does. It just prints it out in decimal and then binary. And then it basically, if you want to extract the answers, I can't remember, was that part of the assignment for you to actually do a print as to whether they were married or not? I don't remember if it was or not. But if you needed to extract the information, in other words, you need to then test and find out so you can do an appropriate print, you can use the AND operator. The AND operator is sort of like doing a test. It's saying the only way that that statement is going to be non-zero is if the bits in both of these values, the corresponding bits in both of these values are set. If they're not both set, then the answer will always be 0. So again, bin data and income mask is going to end up to be 1, because the 1 bit is set in bin data and the 1 bit is set in income mask. Now, if I reset that bit in bin data, income mask, I reset that data, then when I do the comparison, so I reset, I reset the data, the 1 bit in bin data. Now when I do that statement, since they're not, both bits aren't set on both sides, then it's always a 0. And again, let's look at bin data in binary. Okay, it's 1000110. Bin data or the binary of income mask is just the 1 bit. So that bit is set, but that bit's 0. And with an AND, the only time you get a 1 result is when both bits are set. So we go through that and check each answer, essentially. And if this is basically saying if it is non-zero, then print. Okay, so some people might have done this and said, if it's greater than 0, or they might have said if bin data and married mask equal, and this married mask would equal 2. You could do that, and that would be just fine. But with Python, you can do a if statement that results in a where the condition results in a numeric value, in this case a 1 or a 2 or a 4. And if it's non-zero, if the result is non-zero, it's considered true. So if I say if 2 print, it's true, it's true. So a numeric value, as long as it's non-zero, will always be considered true in Python's eyes. If I say if 0, then Python says it's false. So it didn't print it. So you can use that fact by simplifying your if statement. So basically the gist of it is use the OR to accumulate your answers, to set the bits and accumulate your answers in your variable that's collecting all of them, and use the AND the negated and to clear the bits if the answer is no, and then use the and between the binary data and the mask to check if the bit is set or not. If it's set, the result will be non-zero. It'll be 1, 2, 4, or whatever. It'll be some positive number. Okay.
I have 2 questions.
Yeah.
Could you do this whole thing without setting the mask at the top and then just put the numbers instead of income mask, married mask, and all that?
Yeah, you could, if you didn't have the masks, you could do this, or 1. You would have to use, the appropriate numbers, as long as they're a single bit number and you used them consistently. So you could replace all of these masks with just literal values. Would I recommend it? No way.
Why do we use masks then? I need to try to wrap my head around this.
Instead of the literal, instead of this,
Yeah.
because if I'm reading this program, let's say those are gone, and you're reading this program, you're like, well, what does 1 mean? Especially later on, 1 and 2 and 4. You look at that and say, well, what does that mean? What is a 4? What importance does 4 have? So you could certainly use constant values throughout your program. You'd have to remember which answer is which value instead of just remembering a word like married or age or whatever the other one was, income. So you'd have to remember 1 means income. 1 means it means the answer to income. 2 means the answer to married. 4 means the answer to age. And so if you want to remember all that and remember it 10 years later, or not 10 years, but 2 years later, when you look at a program that's 20,000 lines long and you want to know what the hell is a 2? What does that mean? You won't know unless you commented your program really, really well. So you use variables, and I don't have to name a mask. I could have just said income equal 1 and married. Now, I don't have to use the term mask. I just use it because it's appropriate for what we're doing here. We're using these values to mask and to set, unset, and to check the status of a bit. What was the other one? Age.
Okay. I guess that's what was the confusing thing there. I mean, the
So-
term mask, it makes it seem like Python is taking that and doing something special with it, but
No,
really it's
just a
just still a variable.
It's just a variable. The word map, that's just the name I gave the variable because it describes what the variable is doing. It's the mask for finding out about the answer to income. The mask for finding out about the answer for married.
Okay.
Not only
So-
finding out, but also setting or
So I guess almost the power of this program is in those operators. That's what's doing all the heavy lifting in this program.
The operators are doing everything. The variable names are absolutely inconsequential. But when you have variables, when you use variables in a program, which you should always do instead of using constant values, with very few exceptions, you want to name them in such a way that it makes sense, that they are describing the data that they're holding. And so that's why I used these particular names, income, married, and age, because they're describing the information that they're holding.
Okay. And second question I have, the caret on the bitwise operators.
Yeah.
On this chart that's on the lesson, a 0 and a 1 also creates a 1. So what's the caret doing?
Right. So caret is the exclusive OR. the truth table for exclusive OR is a 0 and a 0 makes a 0, a 1 and a 0 makes a 1. I shouldn't say 1. A 0 exclusive OR 0 makes 0. 1 exclusive OR 0 makes 1. 0 exclusive OR 1 makes 1. 1 exclusive OR 1 makes 0. So in other words, it's different than an OR, because an OR is always 1 unless both operands on either side of the OR are 0. Okay, so 1 or 0 gives 1. 0 or 1 gives 1. 1 or 1 gives 1. The only thing that gives 0 with an OR is 0 and 0 or 0. With exclusive OR, where's my little exclusive OR? 0 or 0 gives 0. 1 or 0, exclusive OR 0 gives 1. 0 exclusive OR 1 gives 1. But here's the exclusive part of exclusive. So for now, up until this point, exclusive OR has acted just like OR. But the exclusive part means one, but not both. So in order for a statement to be true, one of the two conditions has to be true, but they both can't be. So 1 or 1 gives you, exclusive OR 1 gives you 0. So it's not commonly used in like if statements and stuff, but you might find a reason for it here and there. Like, like let's say in your program, this program here, if let's say you were going to do something, if they were married, but not over 30, okay, then you could just say if, well, in that case, you're using different bits, but you basically, if your program was to say, if this was true and this was not true, then I'm going to do this. But if they're both true, I'm going to do something else. So it's just a different way to test two conditions. Whereas you normally say, if this is true, or this is true, or this is true, then do something. Or if you say this, if this and this and this is true, then do something. But every once in a while, you'll have a need to say, if this is true, and this is not, if they're both true, then I want to do something different than if just one of them is true. The other place where it's used heavily is, I think you may not have been here for that Zoom session, is in parity checking. If you OR two values together, or exclusive OR, I'm sorry. Okay, they produce another value. If you then exclusive OR either one of those values with the result of the exclusive OR, so the result of that exclusive OR was this, 1, 2, 2, 1. Now I'm going to exclusive OR this with the result, and guess what I'm going to get? I'm going to get that. Okay, so that's useful in parity, like RAID 5 is based on this, RAID 5 disks. So you've got the data is stored on 2 disks, and then the parity is on a 3rd disk. So what they do is they use an exclusive OR operation between the 2 sets of data on the 2 disks to come up with the parity information on the 3rd. That way, if one of those disks goes down, they just have to do the exclusive OR operation again to come up with the missing
I think
data.
that's how the post office sorts mail. I do. They do that. They enter, the computer sees what the zip code is or something.
Yeah, I'm not familiar with that.
That's how it's done here.
But yeah, so exclusive OR is used occasionally. You would use it in like if statements and stuff, but it's used mostly in doing parity type of let's say data reconstruction. You have two pieces of data, you exclusive OR them together to get a third piece of data. If you lose either one of the first two pieces of data, you exclusive OR it with the result, the first result, and you get that missing piece.
Now, in this program that we were just working on here, if we did the exclusive OR, it would technically still work, but it wouldn't be the correct way of going about it, right? Because bin data is 0, and whether the other one's 0 or 1, it would still create a 1.
Correct.
I mean, 1 or a 0, depending.
Correct. It would still, in this particular case, it would produce the same and correct results. But if bin data started off with some answers being true, for example, if the married and age were start off as true, and then once you got to the married question, if they said yes again, and you used exclusive OR, you would now change it to a 0. so now because if the original data was yes and the new data is yes, yes and yes with exclusive OR means no. And so you would really screw yourself up.
Such a weird concept. Yes and yes mean no.
Yeah, exactly. So that's the exclusive OR, but it's if you were to ever study how microprocessors and integrated circuits and how they're designed, it's basically a bunch of ORs, ANDs, exclusive ORs, and NORs, or NORs and NANDs, and not binary operations. That's all a processor like the Threadripper or any Intel any processor ever in the whole world that's ever been made. All it is a bunch of ORs, ANDs, exclusive ORs, NORs, which is not OR, NAND, which is not and NOTs. That's it. That's all it is. And somehow it comes up with everything we do on computers, because it basically all those operations take inputs of electrical pulses that mean 1 or 0. And somehow all this is able to be done with that. But that's there's nothing more to a microprocessor than that. It's just that there's billions of them in a single chip this big. So, and maybe billions might have a chip that big. But all right, anything else on this assignment or any others? All right. Well,
Oh, question. That extra credit assignment, if we turn that in late, do we still get anything for it, or shouldn't matter?
Yeah, I'm giving credit even if things are turned in late. I've been subtracting 1 point as of right now for late submissions. So if you get 9 out of 10 on the extra credit, it's most likely because it was late. But that's still better than 0 points. If even if you get half credit, if you didn't get it all right, you'll get -5 for getting it half right or something, and then I'll subtract 1 more point for being late. But if you get it all right, and then you get 9 out of 10.
Okay.
Okay, anything else? Any other assignments to look at, or just general questions?
Thank you for going over that.
Sure. Hopefully it makes sense. I know this is, especially if you're not real comfortable with binary. You in networking class, we only talked about it relative to IP addresses. And we didn't really, the only operator we used was the AND operator to say that the IP address is ANDed with the subnet mask to get the network ID. But that's about all that we did. And so, you know, throwing the OR in there and the negation and the exclusive OR and all these others can be confusing. When you're going through it and you're trying to figure out what's going wrong, or you know, you're just trying to work some stuff out on your own, you know, it's helpful, I think, to, you know, remember to sometimes just show it in binary. So any number that you send that you put in the binary function will produce the binary string that's associated with that. So that way you can see, you know, what it looks like between the binary and the decimal. And at least for me, it's easier to visualize the AND and the OR operation if I see the binary, the actual bits that are being ANDed together or ORed together.
One thing I was looking for, but I couldn't find in last week's video, is how to get that 0B off the binary.
Okay, so the bin operation produces a string. As you see, it's got the little quotes around it.
Mm-hmm.
So if you want just the stuff that comes after the 0B, then what you want to do, that's where you want to use a slice operation. So I'll do this in two steps. I'll assign a variable to my binary number, and I'll use the same one I just did just for the heck of it. Okay, so now Z is that string. So now what I want is I only want the string starting from the second index value, because that's index 0, index 1, index 2. So that's where you use a slice. So I can just say Z, and then the left brace is the slice, is, you know, says I want one or more elements of Z. And then I say I want you to give me Z starting from the second element, index number 2, and then all the way to the end. Okay, so colon, you know, 2 colon with nothing after it means starting at 2 all the way to the end of the string. And that gets rid of the 0B.
And how would you do that if you wanted to put it all on one command? So you have bin, open parentheses, your value, and then you want it all done at the same time, other than assigning your bin value to a variable first. Just be like that.
Just, whoops, not a dot. Just like that. Since bin returns a string, that any function that returns a string, you can do any string operation, including string methods, with it. So you just do it like this. Okay, so any function that returns a string, you can use the slice operations. You can use any of the methods. So I could even say, I know what the answer to this is going to be. It's going to be true. Oh, well, yeah, it'll be true because it's a 0. But oh no, it's going to be false because there's a B. That's right. So the string 0B is not numeric. It's mostly numeric, but there's a B in there, and that's not considered numeric. But like, you know, the point here is that any function that returns a string, you can use slices and you can use methods with it. You don't have to assign it to a variable in between. You can even with the bin is you can do, let's say bin, let's say 101, or let's say 79. And then I want to get rid of the 0B, but I also want it to be filled out with 8, a whole byte. So backfill with zeros, and that works too. Okay, so bin 79 returns a string. Then we slice that string to say, give me starting from the second element to the end, and then we z-fill that string and say front load with zeros. If I didn't have the z-fill, then it would have returned 1001111. It wouldn't have put that leading zero in there. Okay.
Got it. Thank you.
Okay. If there's nothing else, we'll call it a night. Anything else?
I have a random question. I found this this one thing on GitHub. It was a port scanner for Python, and I noticed it was a lot slower than Nmap, and I was wondering why that would be.
Well, Nmap is a compiled program, and it's also been, it's open source, at least the one that runs on Linux, and probably the ones that run on Windows too. So it's been out there for years and years and been refined by hundreds, if not thousands, of people and iterations of the program throughout the years. And so there's been a lot of opportunity for it to be optimized in its operation for performance. That's one reason, but also it's compiled C. And a compiled language will almost always, I'm not even sure I should say almost. I might even say always, but I'll say almost always because I'm sure there's exceptions. A compiled language almost always will be faster than an interpreted language, which Python is. Python, in order to execute a Python program, a whole series of steps occurs every time you say run. It's got to be turned into what they call bytecode. Well, first off, the interpreter has to make sure that all the syntax is correct. So it does that, whereas the compiler takes care of that before you can ever run the program. With a C compiler, if you have a syntax error, it'll shoot out the error and you'll never get a compiled program. So by the time it's a compiled program, there's no checking to do because it's basically machine level code. Python has to go through all these iterations of the interpreter checking for syntax, and then it turns it into something called bytecode, and eventually that gets executed, close to machine level. But it's a much slower process. Python is reasonably fast for an interpreted language, but it'll never approach a compiled language. Now that's why they have like Python. They have versions of Python that are specifically designed to be compiled into C or translated into C and then compiled into machine level code so that you can write the code in Python and then let the compiler change it into C and then change it into, eventually machine level code. But for interpreted Python like we do here, and like what, most programs that are written in Python are meant to be run, by the Python interpreter, not to be compiled into machine code. And so they're going to be slower. And it's probably not optimized. Like I said, it's probably hasn't had thousands of eyes on it saying, hey, this can be done quicker, better, faster by doing it this way. And that's where an open source sometimes has an advantage because there's all kinds of different people looking at it, and some are good at some things, some are good at others. And so things get optimized.
Thank you.
So just because it's slower though, if so you said you had an Nmap, like an Nmap-like scanner written in Python?
Yeah, I found it on GitHub.
Yeah. So the beauty of that is that you can make a little change in it just for your own self. You can download it, make a little change in it, and run it immediately without having to go through the compile and link. You know, it's a big process, and in compiling someone else's code is sometimes fraught with errors because you have to have all the libraries they're using and everything else. With Python, all you need is the Python interpreter and it'll run as long as it's, you know, written in the correct version of Python. You know, you can't run Python 2 on Python 3 interpreter is what I mean. But yeah, so that's an advantage of getting something in Python is it's easy to interpret Python, I think, than it is C. And so you can see what these programs are doing a lot easier, and you can make changes to them and see what those changes do immediately. So that's one of the main reasons I like working in Python, is because I can immediately see my results. I don't have to compile. And for small programs, it's not a huge deal to do a compile and turn it into an exe, but it takes long enough that it's, you know, annoying. And if it's a big program, like I used to work on programs that were thousands of lines long, I would turn on the compile, you know, tell it to compile and go out and have a coffee or something, or throw the football around for 15 minutes. And maybe when I got back, it would be done compiling. So that's a downside of compiled programs. All right. Anything else? All right. We'll see you next week, or you can on Monday and Wednesdays. I've got office hours, and you can send me an email if you want an appointment outside of those hours. All right. See you around.
Good night.